Right, so these notes are going to summarize some of what we have been doing in our textbook, some of the terminology, some of the skills pertaining to algebraic expressions. So the first thing is that we want to remember what a variable is. And you've been using variables for a very, very long time. But now, instead of a question mark or a box, a variable is a symbol, and usually it's going to be a single letter that represents a number. So back in the old days, you might have had 2 plus question mark equals 5, and you figured out that it was 3. Now it would just say 2 plus x equals 5 or something like that. And they're case sensitive, especially in geometry. A lowercase a means the length of side A versus an uppercase A means the area of a polygon that you're dealing with. So variables are case sensitive as well. The next thing to note is what an algebraic expression is. So an algebraic expression has numbers, variables. Notice the parentheses S just means it could have just one, or it could have multiple numbers, could have just one variable or multiple variables, or a combination of the two connected by mathematical operations. But what we've seen is that for multiplication, the operation symbol isn't always there. So if I have a variable next to a variable, it means to multiply those two, well, eventually numbers that get plugged in. If I have a number next to a variable, they call that the coefficient, and then we would multiply the coefficient times the variable. As a matter of fact, here we have here, if there is a number in front of a variable with no symbol between, that number is called a coefficient. And you multiply the number and variable, so you find the product. Now, all parts of an algebraic expression that are being added or subtracted are called terms. So we have variable terms, and we could have constants. So constants is when it's just a number part. So we don't necessarily have only variables involved. We could have just numbers on their own. Those are called constants. But terms are going to be important to know that vocabulary word, because eventually we're going to do something called combining like terms. So if I have 2x squared and somewhere or other I want to add another 5x squared, that means altogether I have 7x squared. Things like that. We'll be dealing with that throughout this this chapter, as well as later on in a different chapter. You can evaluate an algebraic expression by replacing the variable with the given number, or it could be variables with more than one number, we've seen that as well, and performing the indicated operations. So it becomes like an order of operation problem. Thing to watch out for is that whole idea of a coefficient written in front of a variable. You want to make sure when you write it in, you do add in a symbol so that it just doesn't become a 2-digit or a 3-digit number. It becomes that you're going to multiply. So for this very first one here, evaluate 12 plus 4z when z equals 15. So 12 plus 4 times 15. You can use that dot notation. A raised dot means multiplication. You're going to steer clear from the x meaning multiplication a little bit more than you used to. What you're going to see a lot of as you get more and more into evaluating algebraic expressions is I'll plug it in with parentheses. So that where that variable used to be, you have parentheses 15. So that way you know that it's supposed to be multiplication, because a number next to another number that's in parentheses means multiplication. At this point it becomes order of operation. So you don't do the addition yet, you just have that tagging along. 4 times 15 is 60. And then finally, you can add those together. For the next one, 20 minus 15 over 5. But that division, that fraction bar rather, can also be rewritten as division if you want. But if there's more than one thing happening above that fraction bar, you're going to want to keep it in parentheses. But this could be written as 20 minus 15 divided by if you prefer. But again, at this point, once I've plugged in my number, and I do have to show that step of substituting the number for the variable, then it becomes order of operation. So 20 minus 3 becomes 17. So that's called evaluating an algebraic expression. The other practice that we're going to be having a lot of is writing algebraic expressions. So sometimes they're just giving us this one little tiny phrase and we have to write an algebraic expression for it, versus other times it's going to be a whole scenario and you have to try to piece apart what's going on. So for this practice in the chart below, 36 less than a number, first we want to identify that that's going to be dealing with subtraction. Less than a number, oops, smartboard's not quite lined up, that is a variable. We don't know what the number is. I personally like just use the n for number, but someone else might use an x or your own initials. So it doesn't really matter. But I have 36 less than the number. Sometimes I'm not sure what the order is, so I go, well, what if I had 36 less than 100? It would be 100 minus 36. So n minus 36 would get us putting it in the right order. So if I had said 36 less than 10, oh, now I'm dealing with negative numbers. I'm going to try something else like 100. Try to keep it numbers that seem easy to work with. For number 2, a total of t groups of 6 each. Well, total usually tells us we want to do addition, but in this case, we have a certain amount of groups. Also, each sometimes makes us want to do division. How much is it each? But in this case, we have a total of t groups. We're going to have 6 each. Again, if you plug in real numbers, you might get a better grasp on what's going on. Well, what if I had a total of 3 groups of 6 each? I wanted to know the total of 3 groups of 6 each. That means I'm going to have 3 groups of 6, 6, another 6, another 6 is 18. That's going to be multiplication to get the answer. So multiplication total of t groups of 6 each. So capital T they wanted us to use times 6. But if you wrote 6t, that's the way that more often you're going to see a number times a variable. So t times 6 or 6t, both of those are very frequent ways you're going to see that particular expression turned into an algebraic expression. You're going to try to continue the chart as well as do the practice on the other side for the rest of your